Hello, Testing Festival. My name is WayneAriola, and it's absolutely my pleasure to join you today, this afternoon, at the Testing Festival. I'm joining you from Los Angeles, California, or for the folks in the UK, Los Angeles. I don't know how that happened, but it happens. And coming out of my COVID cave to present to you the open testing platform. For the folks in the audience, if you haven't heard about the open testing platform promotes this idea of inform, act, automate. And the reason why we have come up with this pattern of inform, act, automate is because if you really look at what delays software testing or what delays our practice of actually doing a very difficult task of testing software, is it's usually that we lack the information about change. It's that we are not informed about late changes that could happen or changes that we were unaware of that impacts the testing cycle. And if we were alerted to these kinds of changes, we could take action. So the inform, act, automate pattern is all about connectivity. It's about observing data throughout the dev test infrastructure in order for organizations to take advantage of information and make it actionable. And that's what I'm going to present to you today with the open testing platform. But the idea of the open testing platform truly came from really some observations we saw out in the environment. We saw that there were software testing teams that had a real binary approach to testing. Either that they were testing what they could, or there were teams out there, which was usually led by a global systems integrator that tested everything, okay? And between the two, it essentially has created turmoil, meaning that in the test everything approach, usually we found that the regression test suite or the automated testing test suite was so bloated that when it ran, it created more downstream pain that what the team could actually, could consume. Essentially, it creates more confusion. There was a lack of context associated with the tests that were running, a lack of prioritization associated with the results. And what happened here was in the test everything approach, it creates a lot of confusion. So the alternative to this were organizations that did not necessarily have a great degree of automation, and they used an approach which was test what we can. And test what we can is actually not a bad approach. It uses usually the intuitive reflexes of the team to decide what needs to be tested, and it's usually executed manually. But test what we can actually has a very focused approach. And this focused approach usually comes out with much, much more pointed results, meaning that there's not a lot of noise in the information. But this binary approach to software testing never really focused on one question, which was, how can I reduce the risk of my release? It was basically testing for testing's sake. And if you're on either ends of the spectrum, it was not optimal. The second thing we began to notice was that there was a really highly siloed tools approach, team by team. So one team might have a preference for using Selenium, another team might have its own framework, another team might prefer Cypress. And by the way, this is okay. Software testing teams should have the affinity to choose whatever best fits their project. And maybe it's a talent question where you want to make sure you have the best fit for the talent or the resources that are using or that belong to the team. Or maybe it's an architectural fit where you might choose something that is more, for example, like a Playwright or a React or something that has more affinity to the architecture or the actual language that you're using today. And this is okay. But with the siloed tool approach, we have to start to understand that the open source, free, and proprietary software testing tools today are quite good. They actually offer a lot of very distinct value, but they become nodes in the process. And what I mean by this is they are sensors that deliver information back to some decision node that allows us to move our process or the cadence of our process forward faster. Today, I do believe that we have baked too much business logic into the testing tool itself, basically making it immalleable. So this idea is that we need to separate the logic from the tool in order to actually have the ability to keep the cadence and prioritize our activities for software testing. So in summary, in the siloed tool approach scenario is one, it's a good thing. Open source tools are very productive today. Open source tools can actually assist teams to actually move things along much, much faster. Yet, what we need to do is we need to separate the highly connected idea of the business logic being embedded in the tool itself. And this is why we have come to this conclusion that there needs to be an abstraction, something that assists us to actually take advantage of the tooling as a node. So if we look at software testing today and the software automation and the software testing lifecycle, what you'll notice is even though we talk about automation a lot, what you'll notice is that software testing is really a patchwork of manual tasks that happens in the minutia that happens, or the interstitial tasks that happen in order for testing to work, okay? So if you look across the life cycle in terms of requirements analysis, test planning, test case development, test automation, test data automation, provisioning, test prioritization, so on, what you'll find is the level of automation varies from task to task. But as a whole, we haven't necessarily automated the task of software testing. One thing I want to point out with this particular graph, which I believe is extraordinarily interesting, is number one, if you look at this idea of test case development, this is really where we talk about the idea of automation the most, test case development. If you look at the surrounding scenarios, and let's take environment provisioning as one, that is something that has become much, much more automated over the years. But if you look at the idea of test case development versus this test execution, which is only at 16%, what you're finding is many teams, even though have automation, are still running that automation manually. And we can improve upon this distinctly. So the idea of the open testing platform is that we bring a lot of these components together and allow the organization to truly have advanced automation. And in fact, we feel that data-driven automation, and I'm going to explain that in a minute, can remove up to 70% of the waste, which is delays or manual tasks, in the software testing lifecycle. This is incredibly important. This means that those small interstitial tasks that we have to perform in order for the automation to work, we could actually automate. Test data and test data management, test data automation is a fantastic example of this. No one has really gotten it right yet. And in order for us to really optimize testing, you got to get the data correct. This is just one of the components. Obviously, there's environment provisioning, there is design, there's requirements analysis. All of this should be working in concert for your test and your test automation capabilities. And when we decided, hey, from a Curiosity software perspective, that we were going to go after this idea of the open testing platform, we said, okay, it's got to be a very tight understanding of what's going on. And this is our definition. An open testing platform provides a digital twin, I will discuss that, of your critical business transactions, okay? It is a collaboration hub that connects disparate tools and allows teams to keep pace with change. Okay, let's unpack this idea because I think it's compelling. I think it's what's next from the software testing perspective. A digital twin is something that a team of humans can collaborate against, but it's also an infrastructure that provides a receptor or a way for machine interactions or observations from around the environment to interact with the model. And this is critical. This means that humans have a way to inject new things that are not predictable, but machines also have a way to interact with the model to engage in things like prioritization, the definition of risk, identification of change, information about changing dependencies, and information that allows an organization to keep pace with the very complex array of circumstances that are impacting the model. Now, the digital twin should reflect the most critical business transactions within the environment itself. This gives the team a common understanding of what's important. It also gives the team a launching pad to actually design into or produce tests that surround the core model. But it always relies and gives you the idea that there is connectivity and dependencies between them. And if those dependencies change, then you are alerted. The core of this collaboration and machine interaction via the digital twin is what allows us to take this idea of inform, act, and automate to the next level. So inform basically gives the individual who is responsible for a particular point of the process information about change. And it gives them information about change only when it's necessary. So the idea of inform in the inform, act, automate sequence is that the right information is delivered to the right person only when it's pertinent. We cannot start or continue, I should say, relying on dashboards to provide us information. These are passive. What we need is we need information to land and inform our humans to take the action as required. The second thing is act. And this is action against the digital twin. So any kind of pattern that we can basically identify or promote within the software testing lifecycle should have three components to it. One, the inform pattern, which alerts people to the change or to the into the information that's required. Two is the act pattern. And the act pattern collapses this idea of interpreting change and produces an action within the tool that you're using. So for example, a idea that there's a change in dependency would actually produce an act notification within the model that you're working or the digital twin. This gives the worker or the tester the heads up that something needs to change. It doesn't need to be interpreted by a dashboard. It doesn't need to be discussed in a meeting. It basically lands in the workspace that is required to make the change. And finally, automate. Automate's important because it skips a lot of steps, meaning that if we see patterns that happen over and over and over again, we don't have to take the chance to just recommended action. We can actually create an automated task. This has a lot to do with prioritization, the identification of risk, and how we're actually moving through the infrastructure itself. So let's take another look at this, okay? So let's say you're curating data for testing, okay? And you have various systems in your dev test infrastructure, such as an APM system, version control, web analytics, an agile test management system, or even a defect management system. There is really critical information in these systems. And not only is there critical information in these systems, the correlation between the data we observe within these systems is even more powerful, right? So meaning that if we wanted to take the APM or the application performance monitoring solution and understand that there was a dependency change and reflect that against really what's in the queue for agile test management, or understand where that is from a version control perspective with the code, we would want to correlate those actions. And those would produce much, much, much more specific requests or much, much more specific notifications of information. But we need something to act against. We need this digital twin that sits in the middle. We need this idea that the information that's being correlated or observed from the surrounding dev test infrastructure needs to act against something. And this is why the digital twin sits in the middle. Now, what we could do with the digital twin in the middle is we can inject our requirements or our new user stories into the model. And we can make the manual changes that are reflected by requests from the business or requests from how we are prioritizing our work through epics and stories and whatnot. And we can apply those to the model. And the model then can understand, given those changes, what information is pertinent or what am I missing or required. This creates your gap analysis associated with artifacts. It creates your change workload associated with the tests that need to be created. It creates your priorities in terms of what needs to be addressed within the environment. And then finally, what this infrastructure does do from a digital twin perspective is it auto generates your scripts for whatever kind of framework you're using. So if it's Selenium, if it's Cypress, it's whatever, Appium, or over 100 different tools, the open testing platform understands the requirements, understands the impacts of change, ingests the information or observations from production, and then assists you to create tests that matter. And essentially what we're doing is we're driving this pattern. This pattern is, like I had mentioned before, inform, act, automate. I'm going to give you a couple examples of this as we in the last end of the presentation, but I believe that this kind of infrastructure allows us to eliminate a lot of the hunting expeditions or the archaeology that happens as we do our job day to day. So if you look at an open testing platform, what it does, it's a connectivity environment, right? It takes information from the observed data points from around our dev test infrastructure and allows us to inform teams around the right information on the right time. It then allows us to map against those critical transactions that are really driving our business. So it ties those observations to the impact of business. It can then draw in things like test data and marry it together and auto-generate scripts. But the most important thing about the open testing platform, it's connectivity. It's this idea of having an open framework that allows you to connect data, tools, and workflow. It's your path to the anti-vendor lock scenario, but it's also your path to freedom when it comes to actually leveraging and integrating data throughout your dev test infrastructure, giving the tester information to be extraordinarily productive at any point in the process. So what challenges would an open testing platform solve? Well, first of all, the whole goal of the open testing platform is to be the conduit to identify change. And this can be anything. It can be notifications of change of code, notifications of impacted tests, notifications of changing test scope, notification of changing data, understanding environment changes that could impact the testing activity, understanding whether requirements or user stories are in line with what is the expected in the infrastructure itself or for the release cycle itself, understanding whether feature flags are being worked on that are unexpected. It also focuses on risk. It can actually give you data-driven priorities in real time, allowing you to alter what tests need to actually be constructed and maintained and executed in order to meet the objective of the particular sprint or the particular release cycle. It could show different user impacts, different persona impacts. So if there's a changing persona in how people are actually using the system, that should be notified automatically and not have to be discovered later on down the line. It can highlight risky components, risky code changes, late code changes, changes in scope, and changes in the dependent systems. When you look at execution, this is really critical because this is, I think, where we really get burned in terms of actually executing tests. We need to understand the application dependencies, whether they're internal or external APIs. Those notifications of changes in those dependencies are critical for us to actually executing what we need to execute day in and day out with our tests. Environment access, container changes. This is really config changes within the environment itself. If somebody comes in, explodes your environment, you're going to want to know about it. When you usually find out about it is when you begin to start your testing activity, and that's way too late. And I think one of the most important things about the open testing platform is we're also going to be able to give you information about the quality of tests, whether you have duplicates, whether you have test bloat, whether you have low coverage, over testing, poor tests, false positives, or false negative warnings. This is an infrastructure that allows you to bring that information together in order to make better decisions about the actual quality of your test itself. If I really had to say what's the major benefit of an open testing platform, well, since it's focused on really what to test, the value is not only does it focus you on what you need to do, but also the value of it is it focuses in on what you don't need to do. Today, I think we're plagued with this idea of over testing, and we just don't know how much downstream work it creates. So the open testing platform hones in on what really is required, giving you the ability to actually focus in on the work that's required and necessary to continue what you want to do within your sprint or to meet the conditions of the actual release itself. And I can't imagine even more here, folks, that when you look across your dev test infrastructure, there's a lot of great data out there, and correlating that data to other pieces of information within your organization really gives you some tremendous insight in terms of what you should be alerted to. But you got to remember that it needs to be time boxed. Meaning that if something isn't going to impact the current sprint, it's probably noise. So we got to understand not only what the impact of the changing information is and be able to correlate that across different application or different kinds of data types, but we also got to do it in a time boxed or time horizon manner, which allows us to prioritize how we're going to receive information and how we're going to act upon that information. Okay. So with all that, let me give you a few examples. Okay. So, when you talk about the open testing platform, you got to really look at this idea that we have an infrastructure which allows you to drive change and to react to change faster. So here is one pattern we call an inform pattern. This is a change warning in GitHub. And in fact, the idea is like this. So you have a GitHub commit. The GitHub commit is then picked up by the open testing platform. We basically use our information that we have to understand whether it is correlated or not. Does it impact the current sprint? So we do a time horizon check. Then what we do is we separate this commit to say, is it a brand new commit, or does it actually is it a new commit associated with an existing requirement? With that, we'll actually then provide the analysis or the cross analysis with the other dependent systems and gather the data together, which would actually then shoot it out to whatever your communication preference is. Maybe it's Slack. And within Slack, what we're going to do is we're going to give the tester all the information required, do all the data archaeology for you to say, here's the commit, here's the requirement, here's the developer, here's the last developer who touched it, here's the last tester who touched it, and here are the tests that are actually associated with this particular commit, or here are the gaps associated with this commit. This is timely information delivered to the desktop of the individual in order for us to take action. Now, here's an ACT user story. And this one is predicated on doing a requirements analysis. So a new user story lands in Jira. And essentially what we do is we kick off an automated requirement analysis. And the automated requirement analysis then gives us a pass or a notification for refine, which pushes the requirement back to Jira to say it's not accepted. A passed user requirement would then use natural language processing and actually inject all the fields or components into the model in order for us to advance the construction of testing. So here is a great idea of ACT in which a requirement or a user story is triggered in Jira, and what lands in the actual tester's workspace is a notification that a test needs to be created. But the good part about it is all the components that need to be orchestrated within that test or tied to that new user story land in your workspace. So it doesn't have to be recreated from scratch. This is absolutely critical. The final thing is an automate pattern, and this is change-based testing. So the scenario goes something like this. There's a commit to GitHub. We do the analysis on whether that it actually impacts the current sprint. We actually run through the analysis associated with the other requirements and user stories that are in flight, as well as the impact to the critical transactions which are in flight. And then we reset priorities. Within the model or within the digital twin, the impacted tests are then highlighted, and that notification is sent to the individual in their current, whatever medium they wish in terms of their notification. This is absolutely critical because it's great real-time information. It is understanding what are the impacts of change immediately. And then it also, with the fact that it gives you the notification within the digital twin of the impacted tests, gives you all that information within the central workspace. Okay, I know that was a lot of information, but let me summarize. Within our scenario of the digital twin, within our scenario of the open testing platform, we give you an infrastructure not only for human collaboration, but also for machine injection or machine interaction. This allows you to use real-time prioritization, real-time risk mitigation data to actually prioritize the work. It also promotes this idea of inform, act, automate. And the inform, act, automate pattern, I think, is the most critical breakthrough of the open testing platform. It gives the tester the information they need when they need it. It gives you notifications within your workspace of the actions that need to be taken. And then finally, it gives you the option to automate repetitive tasks that basically occur throughout the whole life cycle itself. With that, Testing Festival, thank you very much for having me. Again, my name is WayneAriola. If you would like a copy of this presentation, please don't hesitate to email me or hit me on LinkedIn, and I don't mind doing it. And I think we're going to have a Q&A after this, and I look forward to your questions. Thank you very much.